Hello students. Today in this presentation I will discuss with you all preprocessor directives. This is a chapter given in your book. We have already covered storage classes chapter, and this is also a small chapter, preprocessor directives, and its topics are mentioned in your syllabus. So we need to cover this chapter. The thing I need to discuss is that when we write a program, when you write the source code, before running or execution of a program, you compile the program. And you have always included two files, hash include stdio.h, hash include conio.h. Let's start with the chapter. Preprocessors are the programs that process our source code before compilation. We always thought that when we write the program, we write the source program on the editor of Dev C++ or any other compiler. The first step is compilation, which will help us in debugging the program, and then the next step is execution. But before compilation, one software executes, that is known as preprocessor. It pre-processes the source code, and it pre-processes all the statements in the code which starts from hash symbol. Hash symbol is shown in the third bulleted point on this slide. This is the symbol for preprocessors. Any line starts from hash is pre-processing statement, and preprocessors are the programs which process these lines before compilation states. Like you have included in the programs hash include stdio.h, hash include conio.h. Those are the two lines that should be processed by preprocessors before the compilation stage. As you can see in this block diagram, you write the C source code, C program, then it is checked whether there is any preprocessor directives. Means preprocessor directives are the commands which are used by preprocessors, and they begin with hash, like hash include stdio, hash include conio. If yes, preprocessors will execute, otherwise it will directly go to compiler. Other Directly, if there are no preprocessors, otherwise it goes via preprocessor step. Always it goes via preprocessor steps, because we have always included hash include stdio, hash include conio, compiler, object code, linker, and so on. That all further steps you all know till execution and output stage. There are four types of preprocessors: macros, header file inclusion, conditional compilation, and other directives. In other directives, you can see on the slide syntax, two are mentioned: hash undef, comma hash pragma. Only hash undef is in your syllabus, hash pragma is not mentioned in your syllabus, so we will cover till hash undef, and all the above three are in your syllabus: macros, header file inclusion, and conditional compilation, along with that hash undef. Let's start with macro. It is an important preprocessor, and let's come to that blue box small example of macro, then we will switch to the theory part of macro. See line number 1. Line number 1 is hash include stdio dot h. This line starts from hash. It means this is a preprocessor directive, and preprocessor will process this line before execution stage. But this is one of the types of preprocessors of file inclusion, because we are including one file, stdio dot h. But now in the third line, second line is the general command, third line is the new line macro, which I want to discuss in this topic. It works as hash define. That define word is fixed, hash define. Now you have written limit, limit, and space 5. It means that we want to give some English word or some symbol to number 5. Hash define limit 5. It means in place of 5 we will use limit in the code, and wherever we will use the word limit, it will be replaced by 5 automatically, and there is no semicolon after the end defining of macro. This is macro, limit is the macro, and the value of macro is 5. Hash define limit 5. Macro, the name of the macro, the template of the macro is limit, and the value and its expansion is 5. See in line number 6 we are using for loop. For int I is equals to 0, I less than 5 we should write, but in place of 5 I have written limit. Automatically macro will be called and limit will be replaced by 5. What is the benefit of this? In the code we want to use this 5 value 10 times, but at any moment we need to change this 5 to 6 or 7, then we need to change the values at the 7 locations. So to avoid that repetition, as well as it can cause errors also, human mistakes also, we are placing one macro by the name limit, and the value of limit is 5. Wherever limit will come, it will get replaced by 5. So if I want to change the value of 5 to 7, I only need to update the line, edit the line number 3. I will only place hash define limit 7 instead of 5. Automatically in the entire code, wherever I want to use 5, where I want to use 7 in place of 5, automatically it will get replaced. This is known as macro. Macro, now I am reading the first point, is a piece of code which is given some name. We have given some name limit. Whenever this name is encountered by the compiler, compiler replaces the name with the actual piece of code. What is the actual piece of code? 5. We have given it name limit. This is a small macro. We can take bigger macros also. Just a small example, that here our code is 5. For 5 we are giving a template limit. Hash define is the fixed directive for using macro, and there is no arguments. Macro with arguments, which is mostly used, and there are many examples in your book when you will read the chapter from the book. Here see line number 3 of the example. Hash define is the fixed directive which we will use for macros. Now the macro name is area, but here area will get 2 arguments, L comma B, and that will be get replaced by L multiply by B. The last bracket is the macro expansion, which we want to replace it. Now come to the main section. In line number 6 you are defining int L1 L2 and area. L1 L2 you have initialized with 10 and 5 value. In line number 8 you are calling area is equals to area, capital area. Capital area is the name of the macro. It means macro is called, but with macro calling you are passing 2 values L1 comma L2. What will happen? From line number 8 the macro will get replaced, macro will be called, and L1 will be passed to small l, L2 will be passed to small b, and those L and B will be passed to L multiply by B. So this will get replaced by complete L multiply by B, means 10 multiply by 5 is equals to 50. At that 50 will be given value will be assigned to small area. Means in line number 8 capital area will get replaced by L multiply by B, and L multiply by B has values 10 multiply by 5, 50 value is given in small area, and that will be printed. So here in macros we can pass values also. This is known as macro with arguments, and this is important as compared to simple macros. But we generally, for passing arguments, we prefer functions, because functions has more error checking, more systematic method as compared to macros, and macros are used for simpler things. Like in the previous example we have used macro for 5 there. And one of the major question macro is macro versus functions, how macros are different from functions, why we prefer macro functions over macros, and similar differentiate between macros and functions. In any form this question can come. I have just picked a table from the internet, but you can use you can in the book the different table is mentioned, and you can try to understand what is the difference. Obviously macro is a preprocessor and function is a compiled. Macro is preprocessed before compilation state, but functions are compiled at compilation stage. No type checking is done in macro, but type checking is done in functions. Complete error checking is performed for functions, but there is no much error checking is performed in macros. Third point is that obviously macro is used for smaller things like 5 l into b, and functions we have developed so many functions in functions chapter also. We can keep any length according to our need. Clear? So everywhere that macro get replaced, so it has do not lead, functions are much mature, they do not lead to any side effect, they do not need to any increase of length of the program. uh, but obviously macro macro is a small code, it get replaced immediately, it is faster. For functions we need to go to that function, execute that function, and come back to the main function, so functions are slower. Before compilation, in pre-processing stage, macro name is replaced by macro value. During function call, we know transfer goes to that function. Macro uses only when small codes are repeated many times, like we have used 5 or l into b, but functions are used for larger code. Macros does not check any compile time errors. Functions obviously at they are compiled at compile time, so they checks compile time errors. So functions are much more advanced than macros. For typical things we use functions, but for smaller value replacement or something like that, we use macros. So this is the macros preprocessor, in which we can use simple macros with arguments, and general question comes how macros are different from functions, differentiate between macros and functions. Next preprocessor, second preprocessor is file inclusion. Just remember that line, hash include stdio.h, hash include conio.h. That hash include is the directive for file inclusion, and we include the file name. That file name is in angular brackets. Always you have seen less than sign, greater than sign, those are known as angular brackets. In angular brackets that file name is mentioned, means that file name is will be searched in the standard directories of the system, and stdio.h, conio.h, string.h, maths.h according to your need of the program, and that file will be searched from the standard directories, and the expansion of the file will be done. Another option in this hash include is we can use double quotes in place of angular brackets in file name, like hash include double quotes, and in double quotes we write stdio.h, conio.h. It means it will search the file in a particular folder of the C compiler. This is used when we develop self-made header files, means when our program is, it is used when we have many large large size of a program, like 2000 lines, 1000 lines, and I want to make half of the program in one file, half of the program in another file, because it is very large to handle. So I created first 500 lines, or created few functions, very large functions, and stored them in one file, and in the rest part of the in the another program I am calling that file to be included in my program, so that my program will not become large. I'm just including the file with the file name. That is known as hash include we can include that in double quotes, because that file is kept in our folder only, in a C folder only, so that we can easily include it, and it will be searched in that typical defined folder. It will not get searched in the standard directories. This is known as file inclusion. Hash include is the directive, and the file name can be included in angular brackets or in double quotes. Double quotes are generally used when we created our own user defined files for a large programs, and as well as it is searched in the local directory. Third is important and interesting, conditional compilation. I have always discussed that a complete program is compiled from top to bottom, one by one. Each and every line is compiled when we click the compile, when we are at the compile stage. But there is two commands, if def. There are two commands, if def and end if. You have done if else. If the condition is true, you will go in the if statement. If def means if defined. Def stands for defined. If defined macro name. If macro name is there, means if macro is defined by that name, then these statements will get executed. Otherwise, these statements will not get executed, which helps to compile a specific portion of a program or skip compilation of some specific part of some on based on some conditions. Like if def, in the syntax you can see hash is a symbol for preprocessor, hash if def is the directive. Further, it is by space, it is named macro name. If macro name is defined, then all the statements will get executed and end of the code, otherwise not. Let's come to this example. In line number 2, one macro is defined Raju, and Raju's value is 100. Now, in line number 6, when we started with main function, in line number 6, the hash if defined Raju, then the line number 7 will get printed, and in the 9, if Raju is defined, yes, Raju is defined in line number 2, so it will get printed Raju is defined, so this line will be added in this C file. Else, line number 9, hash else print Raju is not defined. Suppose we delete the line number 2 of the code, means there is no macro by the name Raju, so else part of this if def will work and Raju is not defined will get printed, and 7th line will not get compiled, will not get executed. Clear? So if defined and else and end if belongs to compilation stage, we are putting restrictions on compilation, because each and every line is compiled, whether belongs to if part or whether belong to else part. But here, when we put the lines in if def else end if system, only that portion is compiled which work according to the definition of the macro. So if Raju is defined, then 7th line will get compiled, otherwise 10th line will get compiled. Here another syntax, if def else and if you know. Now there is one more, 5th line, focus on 5th line, if n def. N is there between if and def. If not defined, it works opposite to the previous one, if def. If not, if salva macro is not defined, then it will execute, otherwise it will not. So we have seen Raju is defined but salva is not defined, so it will work. If not defined, salva, yes, it is not defined, so line number 7 will get executed, otherwise line number 12 will get executed. So here it works according to when macro is not defined, then it will work. Previous one is if macro is defined, then it will work. So two combinations, if def else and if n def else and if. Here in this example you can see another parts of compilation, conditional compilation. Here in line number 5, you are using hash if, only if else and if you are matching it with a particular condition. If a is equals to 100, you are matching the value of the macro, then the lines will get executed, otherwise not. So here means we can use if else and if def else and if n def else and if. In if we are matching the value of the macro, a is equals to 100. Last undefined directive is, which is a special directive, undef directive. Def stands for defined. If there is a macro, undef is used to undefine the macro, means it will delete the macro, it will cancel that macro in the program. See the code mentioned here. In line number 1 we are file. In line number 3 we are declaring one macro height and the value of macro is 100. Now in line number 6 we are just simply printing first defined value for height is that. Now we are deleting that macro, undefining that macro. We are deleting that 100 value to the macro, undef height. Now height has no value. Now again I am defining new, again redefining the macro in line number 8, hash define height 600. Now again macro is defined by the name height and the value of new macro is 600, and previous macro is deleted from the memory. Undef means we used to undefine that. After this statement you can read the statements will undefine the existing macro, so existing height macro will get undefined in line number 7, and in line number 8 we will be redefining that same macro with the different value, undef. So these are the references, few references, and the material is sufficient in your book along with this presentation and video. And I am providing you one assignment, a last assignment of your syllabus, preprocessors assignment. Along with that I am giving questions of storage classes. That is an important topic. These are the two small chapters near to functions chapter in your book. I think chapter number 10, 11 or 11, 12. Storage classes we have covered, scope rules and storage classes chapter we have already covered in the class, and preprocessors was left. I am covering through this presentation. Now I am combining these two topics in a single assignment, and I am providing you that assignment along with this video. You have to submit the theory assignment only, no practical. You can practice yourself. You have to submit the theory assignment, and I will give you one particular deadline so that you can submit. Thank you.